Welcome all to my fourth tutorial in Biostatistics. In this tutorial, I'll be talking about median, which is an average of position which comes under the measures of central tendency. Median is the value of the middlemost observation when the data is arranged in ascending or descending order. So exactly the median will separate the data into two halves. Median will be the middlemost or the centralmost data. If you have a data, median will exactly separate the data into two halves. It is the middlemost item in a set of observation. Then let's see how median is calculated for ungrouped data or individual series. First step is we arrange the data in ascending or descending order, and if the total number of observation is n, consider the number of observation is n. If n is an odd number, for example, here 1, 2, 3, 4, 5, 6, 7, this is odd. 7 observations are there, that means it is a number of observation is 7, that means it is an odd number. If n is equal to odd number, the equation which we apply to find the median is n plus 1 by 2 the item. N plus 1 by 2 item will be the median of observation which is having n number of observation. Then for if n is even, n is an even number like 6, 8, 12, 24, 36 like that. If it is an even number, the equation which we apply is n by 2th item plus n plus 1 by second 2th item, the whole divided by 2, or simply it is a average of n by second item and n plus 1 by second item. That is what is median of odd and even number of observation. Now let's see an example how to calculate. The question you can see here, it is a weight of earthworms which is recorded as 6, 7, 4, 5, 5, 3 and 4 from a soil sample. Then the first step, if you get a question like this, the first step what you have to do is arrange the data in ascending or descending order. If you arrange the data in, this is the question, arrange in ascending order. So first is 3, the lowest value is 3, then 4, next to 4, 5, 2 measurements comes 5, and 4 is also repeated twice, 4, 5, 5, 6 and 7. This is arranged in a ascending order. Here the total number of observations we have to calculate 1, 2, 3, 4, 5, 6 and 7. The number of observation or n is equal to 7, and 7 is an odd number. So to find the median, the equation which we use is median is n plus 1 divided by 2. Here n is equal to 7. So 7 plus 1 divided by 2. That item will be the median. So 7 plus 1 is 8. 8 divided by 2 is equal to 4, or fourth item or fourth observation in the data is the median. So the fourth observation here is 1, 2, 3 and 4. So the answer is 5. Fourth observation is the median. So here the median is equal to 5. This is how to calculate the median of observations or data which is having odd number of observations. Now let's see how to find the median if the number of observation or n is a even number. This is an example. Let's work out this question. This is an example showing the number of jasmine flowers in 8 plants. The first step, look at the question, and the first step what you have to do is arrange the data in either ascending or descending order. I am here writing in the ascending order. So 35 is the lowest value, 36, then 38, 39, 40, 41, 42 and 44. And here n is equal to 8. That is counting how many numbers are there. 1, 2, 3, 4, 5, 6, 7, 8. 8 number of observations are there. Median is calculated by, we find median by applying this equation, that is n by tooth item plus n plus 1 by tooth item, the whole divided by 2. So here n is 8. So 8 divided by 2 plus 8 plus 1 divided by tooth value by 2. 8 divided by 2 is 4th item or 4th observation, plus 8 plus 1 is 9. 9 divided by 2 is 4.5 divided by 2. That is equal to, which we have to, now we have to substitute the 4th item in the observation. The 4th one, 1, 2, 3, 4. This is the 4th item. We have written here 4th plus 4.5. 4th item is 39. So we are substituting this 39 here. 39 plus 4.5 item. That means which is coming between this 4 and 5th, after 4th and 5th. So it is 40. 4.5 item is the item which comes between 4 and 5, and that is after 4 it is 40. So 39 plus 40. These are the two values which we take, 4th and 4.5. 40 divided by 2, that is equal to 79 divided by 2, that comes to 39.5. So 39.5 is the median value in this set of observations. Now let's see how to compute the median of grouped data or discrete data. So in discrete data, the data will be given in frequencies. In computation of median for grouped data. So in grouped data, the main thing which we have to be careful is we have to find the cumulative frequency and arranging the data in the ascending order as we did now. And here in the group data, the equation which we apply here is the median, that is n plus 1 divided by second item, where n is equal to sum of frequencies. That thing has to be noted. Here in case of this group data, n is the sum of frequencies of f1 plus f2 plus till fn. That is, n is the sum of frequencies. It is. Then now let's see how to calculate or how to find the median of a question which is given here, in which it is a protein content of 100 bivalves in gram. And in this table you can see the protein content and frequency. First step is to make a table with 3 columns. The question is, you have to arrange it in the ascending or in the descending order and make a table with 3 headings. First is protein content. Second is frequency. Third is cumulative frequency. Cumulative frequency we have discussed in the second tutorial, how to calculate the cumulative frequencies. Cumulative frequency. Then protein content is 5, 5.5, 6, 6.5, 7, 7.5 and 8, 8.5. Then frequency is given here: 2, 4, 8, 10, 15, 2, 25, etc. And here cumulative frequency has to be calculated. That is, cumulative frequency in this column it's 2. Cumulative means adding up. So here the cumulative frequency is 6. Then 6 plus 8. That comes to 14. 14 plus 10, that comes to 24. Then next is 39, 64, 86 and 100. You have to add. That is how cumulative frequency is calculated. Then now let's see how to find the median. This is the first step. Arranging the data in ascending order. Then based on the frequency. Then next is cumulative frequency is calculated. Now let's see how to calculate the median. Median is equal to size of cumulative frequency plus 1 by 2 the item, that is size of, the equation is shown here, that is size of cumulative frequency, the total of here I told you n is equal to sigma f, that is in this question sigma f is 100. Number sigma f or number of observation n is equal to 100. So the median is calculated by, median is equal to size of n plus 1 divided by tooth item. And here n is equal to 100, that is 100 plus 1 divided by 2, that is equal to 50.5th item. 50.5th item is the median, and we have to find where the 50.5th item comes in this table. That is the cumulative frequency. You have to check here in this data the value or the cumulative frequency 64. After we have 2, 6, 14, 24, 39 and 64. So the number 50.5, the median we have calculated here, it is 50.5. The number 50.5 comes in between 39 and 64. 50.5th item. So 50.5 is 5 is between 39 and 64. So the value here is 50.5th item will be coming in this row. So 7.5 is the median. Median is equal to 7.5. Hope it's clear. So if you have a group that is grouped data or discrete data, two things. First, we have to arrange in ascending order, make a table with 3 columns, calculate the cumulative frequency, then apply this equation n plus 1 by 2th item, and we have to find where this value or value comes, and that measurement of the data will be the median of that data or observation. Here the answer is 7.5. Now let's see how to find the median of grouped data of continuous series. In continuous series, the equation which we apply here is displayed on the screen. That is, median is equal to L1 plus n by 2 minus C the whole divided by F into H, where L1 is the lower limit of the median class, F is the frequency of the median class, E is the cumulative frequency of the class preceding the median class, N is the total number of frequency or sigma F, and H is the width of the class interval of the median class. Now let's see an example. This is a question which showing the fecundity of 50 poultry bird species. The question is displayed here, and the first step, as I said, is make a table with 3 columns and calculate the cumulative frequency. In finding the median, the first step is write the data in ascending or descending order, and if it is a grouped data, you have to split the table into 3, in which cumulative frequency is also calculated. And this is a table which is showing here the cumulative frequency. 3, then 11 to 20, 15, cumulative frequency is adding up, that is 3 plus 15 is 8. Then next is 21 to 30, 31 to 40, 41 to 50, 51 to 60, 61 to 70, 71 to 80. And the values here is 2, 8, 11, 4, 1 and 6. Now here goes the cumulative frequency. This is a column for cumulative frequency. This is frequency, and this is the class interval or the fecundity. Now let's see the cumulative frequency. 18 plus 2 goes to 20, then 20 plus 8 goes to 28, 28 plus 11 goes to 39, 39 plus 4 goes to 43, then 43 plus 1 goes to 44, 44 plus 6 goes to 50, and we have to find sigma F. I told you in the beginning, sigma F, or the total of the frequency, is the value of n. N is equal to simply sigma F, or total of frequency. Here sigma F is 50, which is a even number. The next thing what you have to do is you have to apply the first step is over, that is make a column, make a table with 3 columns in which cumulative frequency is calculated. Calculate sigma F, that is 50. The next thing is here the value n. You can write n is equal to 50, and the first step here is to find the median class, and median class is the class in which the median value lies. So first step here is you have to find where the median lies, that is median is lying in, because 50 is an even number, median lies in the is calculated, is found by using this equation n plus 1 by tooth item, that is 50 plus 1 divided by tooth item, that is equal to 51 divided by 2, or 25 point tooth, 25.5th item. So median class is a class in which 25.5th item lies. So here we have to see where this 25.5 is coming. 25.5 comes between 20 and 28. So after 20 comes 25.54. So this is the median class. Median class is the class in which the 25.5th item lies. So that is the second step. First, making a table, calculating with the cumulative frequency. Second is to identify which class is the median class by using this equation. Then 25.5th item lies in this class. Now let's see. So this class, that is 31.8 in class interval, is the interval in which the 25.5th item lies. Now let's substitute the values in the equation, and the equation I mentioned earlier, that is displayed here. Let's substitute the values. The equation M is equal to L1 plus N by 2 minus C by F into H. That is, L1 is the lower limit of the class, of the median class. L1 is the lower limit of the median class, and so here L1 is equal to 31. 31 is the lower limit of the median class. This is the class interval. Lower limit of the median class is 31. So L1 is 31. Then N, we have written here the number of observation, that is 50, divided by 2 minus C, and C is the cumulative frequency of the class preceding the median class. C is the cumulative frequency of the class preceding the median class. So this is C, cumulative frequency of the class preceding the median class, that is C. So here C is equal to 20 divided by F, and here the value for F is equal to 8. 8 is the frequency of the median class. 8 is the frequency of median class into class width, that is this difference 31 to 40. The class width I've mentioned in the previous tutorials, class width is equal to 10 into 10. And you have to substitute. Let me tell you once more. L1 is the lower limit of the median class where the 25.5th item lies. N is the total number of frequency that comes to 50. Then C is the cumulative frequency of the class preceding the median class. Then H is the difference of the class interval or the class width. H is class width, and 8 is the frequency of median class. And you can substitute the values, and after calculation the result comes to 37.25. That is about how to calculate the median. Now let's see the merits and demerits of median. Coming to the merits, it can be easily calculated and exactly located. That is important. Exactly we can locate the median value. Then it does not get affected by abnormal large or small values. If any small or large values are added, it does not make much difference in the calculation, and its size cannot be changed by adding few more items. And median is used in quantitative measurements, and the demerits are 2 or more series cannot be computed using the median of the component series, and it can also not be used where the weightage is given to some items. All the items have equal importance while finding the median. With this, we come to the end of this tutorial. Thank you.